Are you feeling too hot, too cold, or maybe just right? That feeling of thermal comfort is something we're all chasing, all the time. But what if I told you that the way we design our buildings, our entire approach to staying comfortable, is based on a myth, and that getting to the truth could end the thermostat wars and slash our energy bills? Well, let's dive into the science of comfort, because there's a really surprising truth about how we're all wired.
I mean, we've all been there, right? The thermostat wars. It doesn't matter if it's at home or in the office, someone's always freezing while the person next to them is melting. It feels like finding one single temperature that makes everyone happy is just impossible.
That whole struggle is actually rooted in a really old-school way of thinking. For decades, engineers and designers have followed what's called the steady-state model. It's this idea from back in the 70s that there's one single perfect temperature, a magic number that you can calculate and maintain for any indoor space, for everybody. But here's the thing. As anyone who's ever had to wear a sweater inside during a heat wave can tell you, that one-size-fits-all approach just doesn't work in the real world. So researchers started to question that core belief, and they set out to find a smarter, more adaptive way to think about what makes us comfortable.
Yeah, the big problem was when scientists actually went out and tested this model, its predictions were just wrong. Especially in buildings without central air conditioning, what they call naturally ventilated buildings. People in those spaces were perfectly comfortable at temperatures that the model said should have them complaining. It was clear the old model was missing a huge piece of the puzzle. Us. It wasn't accounting for the human factor.
So how do you crack the code? Well, researchers realized they needed data, a ton of data, from real people in their real, everyday environments to figure out what was actually going on.
And here's how they did it. We're going to be looking at a major study from the journal Building and Environment. Now, instead of starting from scratch, they did something called a meta-analysis. Think of it like a super study. It takes a whole bunch of smaller studies and combines all the results into one massive, really powerful data set.
So, they started by gathering up the data from 11 different comfort surveys that were all conducted across Southeast Asia. And in total, get this, these surveys gave them over 5,000 individual observations, each one documenting the physical environment and, most importantly, how people said they actually felt in that moment.
And just like that, they had created one of the most comprehensive databases on this topic ever put together for that region. Okay, so now with all this data in hand, they could finally see the real patterns of human comfort.
So, what did all this data show them? Well, it revealed that we are not passive victims of the temperature around us. Turns out, we are constantly and very predictably adapting to it.
And this slide pretty much illustrates the core finding perfectly. In naturally ventilated buildings, think of a space where you can actually open a window, people were totally happy at warmer temperatures. But in those sealed, air-conditioned buildings, their comfort zone shifted, and they preferred cooler, more stable conditions.
And the numbers make it crystal clear. The average neutral or comfortable temperature in those naturally ventilated buildings was almost 28 degrees Celsius, but in the air-conditioned ones, it was nearly 2 whole degrees cooler. So it turns out our idea of what's comfortable isn't set in stone at all. It's directly shaped by the environment that we're in.
Okay, now this visual is fascinating because it shows us that difference so clearly. Each of those bubbles represents a group of comfort votes. Now notice on the left, for the naturally ventilated buildings, the bubbles are kind of spread out across a pretty wide temperature range. But now look at the right, for the AC buildings. See how those bubbles are all clustered tightly together? That shows us that the comfort zone gets much smaller.
But hang on, because this is where the story gets really mind-blowing. What if there was a way to measure temperature that actually accounted for our human adaptations? A metric that could see past the simple number on the thermostat?
Well, there is one. It's called Standard Effective Temperature, or SE star for short. It's a much more holistic way of measuring comfort. So it doesn't just look at the air temperature, it also considers things like the breeze from a fan, the humidity, even the kind of clothes you're wearing. Basically, it's about how the temperature feels to your body. And look what happens. When the researchers reran the whole analysis using this metric, the difference just disappears. The comfort point for both groups suddenly becomes almost identical. This is amazing. It proves our true comfort is about our total thermal experience, not just what the thermometer says.
So, because this whole process of adaptation is so predictable, it means we can finally move beyond that single fixed number and create a much smarter formula for what true comfort is.
And here it is. This is the new adaptive comfort model that came from all that data. The idea is actually super simple, but it's revolutionary.
Our ideal indoor temperature isn't fixed. It actually rises and falls in a straight line right along with the average temperature outside. So as we get used to warmer weather outside, we feel more comfortable at warmer temperatures inside.
And what this means is that we really need to stop thinking about one single perfect temperature. Instead, look at this chart. We should be thinking about an acceptability range. That whole shaded area shows that for any given outdoor temperature, there's a whole band of several degrees where people will still feel perfectly fine.
And just how wide is that band? Well, for 80% of people, the comfortable range is a whopping 5.7 degrees Celsius wide. We are far more flexible than our old building models ever gave us credit for. So, why does all this matter? I mean, it's cool science for sure, but it completely changes how we should be designing and operating our buildings, for the better.
And here's the big number I hinted at earlier. This is huge. The study points out that by using an adaptive approach, instead of just locking the AC to a single cold temperature, we could save around 30% on cooling energy. That is a massive number.
And the benefits just keep stacking up. We're talking huge energy savings, which means a significant drop in our carbon footprint. We're talking about healthier indoor environments that are more in tune with the world outside. And the result of all that? People who are actually more comfortable and more productive. It is a win-win-win across the board.
You know, it leaves us with a really fascinating final thought. If our own comfort is so closely linked to the world outside, maybe the smartest thermostat isn't one we fight over at all, but one that simply checks the weather forecast.